well, no, I was on the wrong page. Now I'm on page 23. And I actually just created these problems myself. Like, they're not in the book. But it's this section. Okay, hi. We are reviewing for the exam. We are on review day part 2, and we're on section 1-4, properties. So I pulled these examples from my brain, not necessarily from your book, but in this section of the book is where we are talking about properties, and these are the ones you need to know for your exam. So does anyone remember what the property is when we have some number plus 0 and it ends up equaling the same number that you started with? No, but that was a good guess.
What did you say?
It would be 0. It would be 0 property. Hold on, I spelled that wrong. If we were doing multiplication. But because it's addition, it's called the identity property. So 0 property for multiplying, but identity when it's plus 0. How about when you have the same numbers on both sides, but they're just moved around? What's
Commutative.
Good. Commutative property. You can almost hear the word move in the middle of commutative. I mean, not really, but I'm trying to help you here. Okay. So commutative property means the numbers moved around. It doesn't change the answer. It just changed the order of the numbers in the problem. So number 3, remember, there's always an imaginary 1 sitting under every number. So what is it called when we flip a fraction?
Identity.
Starts with an I. You're on the right track.
Identification.
Nope. Any?
Inverse.
Inverse. Yes. Very good. Inverse property means you're just flipping the number over, multiplying, and it's going to equal 1. So the inverse property means they took an original number, flipped it, multiplied, and they got 1. Okay, so number 4 is the one with the parentheses. The parentheses move around, but the numbers don't move. Yes, very good. Associative. Associative property is where the parentheses move, but the numbers don't. And you still get the same answer no matter what order you do it in, as long as you're just multiplying or adding. And then the last one, I heard somebody say, distributive. Good. That means we took what was outside the parentheses and we multiplied it on everything inside the parentheses. And that's the distributive property. Okay, copy this down and we'll be right back. Okay, section 1-5 is the distributive property. And on this property, remember, it says that whatever is outside the parentheses has to be multiplied on whatever is inside the parentheses. So I'm going to draw my little lines because even, yes, after all the math I've been through and being a teacher, I still draw the lines so I don't forget and I don't get lost. So 6 times 12, anybody know that?
2? No. 6 times 12.
72.
Good. And 6 times -2? -12. Now, what do you notice about 72 and 12?
Well, they both end in 2.
Yep. What else?
Well, one's positive, one's negative.
Yep. What else?
The half bigger numbers first.
Yep. What else? Yeah. Are they the same type of term?
No. Yes.
They're both numbers, right? Do they have variables? No. So that means I can combine them still. I'm not done. What is 72 minus 12? 60. So my final answer is 60 for that one.
Wait a sec. 72 minus 12?
Take the 7 and the 2, put the 7 on top, and then, okay.
And then subtract.
72.
Ethan, did you get it right?
You
All
put the 2 zeros
right.
minus 2.
Okay. So, next one. I'm distributing again. What is 2 times 4?
8.
8. And what is 2 times x?
2x.
2x. Now, Are these two terms the same? What? No, they're not the same because one has what? A variable and the other does not. That means I can't combine them any further. I'm just done right here. 8 plus 2x is my answer. And number 8 looks weird because the number outside the parentheses is on the back. But it doesn't matter. We're still going to use the distributive property. And we're going to multiply. So I like to go on to the first term first and then the second term. So I'm going to do 9 times g, which is what? 9g. And then 9 times a minus 5. Negative 45. Good. And again, their terms are different. One has a variable and one does not. So this is the answer. All right, how about number 9? Simplify. Now we're combining like terms again. So 13m plus m, how much is that?
13
13
Nope.
squared.
Nope.
13 to the
No, if you were multiplying it would be that.
oh,
But we are adding, so remember there's an imaginary 1 right there. So how much is this? 14m. Just write the variable one time, add or subtract the numbers. Okay? All right, so number 10 looks like it's got some distributive property and probably something else to do. So 3 times x and 3 times 2x, 6x. Now look, I have like terms, so I'm going to keep adding. What is 3x plus 6x?
9x.
There you go.
Yes.
And then number 11, I have to look for like terms. So which terms on 11 are alike? Two of them. Which two? Yes, the x's, because they're both just one x. The x squared is going to remain over here by itself, because I can't put an x squared with just an x. So what is 14x minus 9x?
5x.
Yes, it's going to be a positive 5x. And so my final answer would be 6x squared plus 5x. All right, copy that down and we'll be right back.
Blah, blah.
Okay, this section is called commutative and associative properties, but all it's teaching us is that when we're adding or multiplying, it does not matter what the order is that you add or multiply. You're still going to get the same answer. So I could do 17 plus 13 first, or I could do 6 plus 17 first, or I could do 6 plus 24 first. It doesn't matter. I'm going to get the same answer as long as I don't add a number twice. So I underline what I'm adding first, and I picked those two because I know 3 plus 7 is 10, and those are like easy for me to add in my head. So 17 plus 13 is 30. And then I'm going to bring down what I haven't used yet. And next I'm going to add these two because I know those two also will add to 30. So bring down that 30, write the new 30, and then 30 plus 30 is 60. So in this section, you're just going to be solving problems like this. You just have to remember the order doesn't matter. So solve it in whatever order you want. Now the exam is going to be on a Google form, but you have to show your work on paper if you're in class or if you're at home. So you're going to have to write the problems down and show me your work so that I know you did it. All right. All right, so for number 13, what should I multiply first?
3 and 10.
Okay, 3 and 10. So what is 3 times 10?
30.
Yep. And then bring down the rest. Next.
6 times
Okay, what is 6 times 3?
3.
18. And then last, 30 times 18. So who has their calculator?
I do. 3.
Yep.
3, 0.
300. 540.
540.
340.
It was a race. Ethan won. Okay, great. Rayleigh's mad. It's okay. Get over it. Okay, 540. Next section is just what we did in the last section, but more terms. So it's combining like terms. This what we did in section 1-5, where we combined our like terms. That's what we're doing now. And what's wrong?
It says 1-6.
I know,
Oh,
but these two problems, 14 and 15, are very similar to problems that we did in the last section.
okay.
But you're going to see more terms in these problems. They're a little bit longer. So, for my first one, what are my like terms in number 14?
And then
4a and a. So what is 4a plus a?
4, 1, 4,
No,
5A.
5a. They got it at the same time. And then just bring down your 2b. Now, can I combine those two?
No.
Why?
That's a beginning.
Yep. Different variable. They have to stay apart. So that's your final answer. Okay. What about... You can just talk.
Okay. Never mind. You'll know in 4 minutes.
Okay.
When it ends.
Oh, okay. Thank you. Yeah, keep me posted because I forget to watch the timer. All right. So the next one, what do I have to do first in this problem? Yes, I have to do the distributive property first. So what is 2 times 2x?
Oh, wait, what?
4x.
There's that one number out of
Yeah, no, wait, that's a 2x plus 7.
Let's say 17 or 7. That's
What is 2 times 7?
Oh, okay.
14. And then bring down that first term because we didn't use it yet. Now, what are my like terms?
x plus 6x plus 4.
What is 6x plus 4x? 10x. Bring down the 14. Can I combine anything else?
No.
No, because I have a variable with just a number, so I'm done. Okay? Okay. This is logical reasoning. So remember, you have a hypothesis and a conclusion. And your hypothesis is the if part of the sentence, and your conclusion is the then part of the sentence. So when you see number 16, the directions are identify the hypothesis and the conclusion of each sentence. So that's what we're going to do for 16. And the hypothesis of number 16 is what? Both parents have red hair, because it's the if part. Oh no, I'm going to run out of time. I'll try to be fast. Okay, and then the conclusion is what?
Then their children will have red hair.
Their children will have red hair. And for number 17, it says to write an if-then statement for this sentence. So I have to look at this sentence. The trash is picked up on Monday. What could be an if-then statement for this sentence?
If the trash is picked up,
Yes.
then put it out on Monday.
So the trash picked up, and today is Monday.
So,
Then, yes, then it is Monday. Or you could say today is Monday.
Yeah.
Okay, if the trash is picked up, then it is Monday. And that's all we have time for today, and we will be back on Monday with more review. So have a great weekend, and let me know if you have any questions. And there's no homework, you're just practicing IXL skills from Google Classroom going back to the beginning of the year. And that's all. So study, let me know if you need help. Bye.